Now let's think about another way of looking at the spread of a sample, which is the standard deviation. So we write the standard deviation as the letter sigma, Greek letter sigma, for a population. If we're looking at the spread of a whole population, whereas we write it with the English letter S, we're just looking at a sample of a population, and there's a little difference in how they're calculated, as you'll see in a minute, but it's the same principle. And they both, the point of the standard deviation is to describe how spread out your measurements are. So I'm just going to show you a graph to demonstrate what I mean. So here we've got the frequency of the measurement, and this and here we've got the measurement itself. So this could be hand sizes, and this could be the number of people with hands that size. And I'd like to point out that this is assuming a normal distribution, which you'll hear about elsewhere, but it implies that measurements are spread evenly around the mean. So let's imagine an example which has two different populations, each with the same mean. So the mean would be here, but we could have two very different populations with that same mean. So for example, we could have one where the measurements are quite close together, or this one where they're more spread out. In fact, I'm going to be more extreme with that blue one. Okay, so these are both spread out evenly around the mean. However, the blue one has a low standard deviation because the measurements are grouped closely together, whereas the green one has a high standard deviation because the measurements are quite spread out. So that's the general principle of the standard deviation, and you'll be learning more about this elsewhere. But let's just work through the equation, the formula of how you calculate it, and to do that we need to have a little think about what it means. So it describes how spread out your measurements are, but in fact what we're asking is, on average, how far away from the mean are your measurements? So we're looking at each measurement and seeing how far it is from the mean. So in fact we need to start by going through something called variance. So I'm going to show you the formula for variance, which is S squared, and that is equal to the sum of x minus the mean squared all over n minus 1. So let's break down what that means. So we're asking, on average, how far away from the mean are your measurements? So first of all, this part is telling us the distance from the mean of each measurement. And then we square it so that all the measurements are positive. And then finally we do the sum, and we divide by the number of samples. So it's n for a population standard deviation, n minus 1 for a sample standard deviation. Let's not worry too much about that. But the point is that this is the same as taking an average. So we're summing these distances from the mean and we're dividing it by the number of samples we have. Okay, so we're looking at the distance of each mean from the measurement. We're squaring it just so all the signs are the same. And then we're adding those together and we're dividing it by the number of measurements we have. And it's n minus 1 for a sample mean, whereas it's just n for a population mean. So n minus 1 for the sample mean, that's just to do with degrees of freedom and stuff like that. But you just need to remember it's n minus 1 for a sample. This is most often what you're going to be doing. Right, so that's variance, and then simply standard deviation or S, that's just the square root of that. And this is in fact what we use by far most often, is the standard deviation. So that's the square root of the variance. So we could say it's the square root of the sum of x minus the mean squared all over n minus 1. So that is the formula for the standard deviation of a sample, and I'd want you to remember that formula in your exam.